Hi everyone, welcome to the last video of the cohort. In this video, we're actually going to cover a couple of topics. So basically, we will try to deploy our polled app to one of the test nets. So we'll understand what a testnet is. We'll understand how to use MetaMask wallet and several other tools like Etherscan and the Robston faucet. So let's get started and we'll iterate over each of these topics one by one. So let's open our remix ID again and we'll go to our old app contract. So we won't focus on the factory, we'll focus on this because in this video we're actually covering how to deploy these contracts to the testnet, not anything related to Solidity per se. One thing that you will need to do is you will have to install the MetaMask wallet. So for that you can go to metamask.io and you will see the download button here, and it is very straightforward. It will explain all the steps that are slightly complicated during the flow, and once you follow them you will have a wallet setup. Next thing that you want to do is, by default it will be on the selecting the Ethereum mainnet. What you want to do is you want to click on show or hide test networks. If this toggle is off, you want to turn it on, and then you want to select the Robston testnet. So what is the Robston test network? Basically, as you know that when you deploy any contract to Ethereum, when you deploy any code to Ethereum, you have to pay gas fees. So, you won't want to do that until you're confident that it works. For that purpose, testnets like Robston and several others like Rinkebai, Kovan, Gorley exist. You can actually use your own testnets if you have them running on a local host, but we will not be covering that. So coming back to Robston, we select Robston because Robston is a relatively robust and commonly known test network. And the general development flow with Ethereum is that you deploy everything to a testnet. Once you're happy with it, then you deploy it to the mainnet. And the procedure is exactly the same as Robston as it is on Ethereum. So if you can deploy something on Robston, you can just as easily deploy on the mainnet. The only difference will be in spending the actual money. So I'm going to select Robston, and as you see, I have some ETH. Now this is not real ETH. This is again the test network ETH, and it is only there to emulate real world behavior, which is, the real testnet's behavior. The real mainnet's behavior. So how do I get ETH on, a testnet like Robston? I will need ETH to perform operations like calling functions, deploying contracts, but I need to first get this ETH. So for that, there is such a thing as a faucet. Now, a faucet is basically a tool that can generate Ethereum for you. So since a faucet exists on a testnet, it obviously means that Ethereum has no value since you can generate it on demand. One testnet that we are going to use is the Igor Fine. I don't really know how to pronounce it, but it's faucet.igorfine.com. So all you have to do is you have to go to this. You have to make sure that you are on the Robston test network. You copy your address, paste it in this field here, and then give me Robston ETH. It says address limited, please retry in a day. The reason it is saying that is because right before this video, I actually already requested ETH on this address. Let me see, just for demo purposes, if I can switch to a different address and get ETH. Yeah, so I think it's actually looking at my entire chain of addresses and not letting me get ETH, but it will generally work. So you just paste your address here and you click on Robston, give me Robston ETH, and after a few seconds, it will show up here. Now let's go back to our IDE. So now we have MetaMask installed. It is pointing to the correct test network, and we have some ETH acquired. Our flow for deployment is going to be very, very similar to what we have been doing. The only difference is that when you go to this deploy and run transactions extension, instead of JavaScript VM, you want to select injected Web3. And as soon as you click that, let me see if I can zoom in here. As soon as you click that, you will see that it says Robston 3 network. So what is injected Web3? Basically, MetaMask is putting, injecting the Web3.js library into the browser, which is why it says injected Web3. So you can actually see that here. So if you go to your console, so I just opened the browser's console and I'm going to type in Web3 here and I will see this object. This object is coming from this extension, and this, since this extension is connected to Robston, which is why we see this here. Another thing you will notice is that, let me expand this bar a little bit. This address, the 0x124 dot dot dot, is the same address that I've selected here. So if I were to change it, it will change the address selected here as well. So again, very similar to what we had been doing with JavaScript VM, we are pretty much following the same steps, except that we are doing it on the Robston testnet. So how do I see what is happening on the testnet? For that, we have a tool called EtherScan. So before I go to that, let's try to deploy this contract. So again, I'm going to zoom in. I'm going to add a polling lab question. What is the best testnet? And I'm going to put in the options as let's say Robston, Rainkebai, and okay, it's spelled fine. Go early, and let's say localhost as well. So we have 4 options, and now I'm just going to click on deploy. And now as soon as I click on deploy, it's going to open this Robston, the MetaMask extension, and let's navigate what is happening here. So it is giving me an estimated gas fees. Now this gas fees is basically for the transaction that I'm making. The transaction is a contract deployment transaction. So in JavaScript VM, since it was not a real network, it was just happening in the browser. This did not open up. But now since we are actually sending a real transaction to the testnet, it's asking me permission. So it is saying that it will cost me this much gas fees and the total amount is this much. This is very similar behavior to what would happen in the mainnet. Now it will also show you the data, and I will go back to details and I'll click on confirm. Let's see what happens then. It gives me a link called view on EtherScan. So what is EtherScan? Let's open this and see. Now EtherScan is basically a service that lets you scan, as the name suggests, what is happening on several testnets, or even the mainnet. The URL here is robston.etherscan.io, and it says tx/a transaction hash. Now this transaction hash is basically what is identifying the transaction of contract creation on the Robston testnet. Now it will have a bunch of information. It has the transaction hash, it has the status, and several other details that are still under process. Now, like I said, the Robston testnet very closely mimics the real mainnet. In that attempt, it will actually have some delay in the time that the transaction is mined. So unlike the JavaScript VM, where as soon as we click the deploy function, the contract is deployed, Robston will take some time because this transaction is actually getting mined, very similar to the behavior on the mainnet. Let me refresh this page. And yeah, as you can see, the status is now success and the contract is available here. Now we have a slight problem. The problem is that earlier when we deployed on JavaScript VMs, we could interact with the code here. Now we can continue to do that because this remix ID actually makes the contract available for interaction here. But what if I had deployed this contract from some other tool? How would I interact with it? That problem is solved by EtherScan. So when I open contract right now, it will only show me the bytecode, but it has an option which is verify and publish your contract source today. Let's see what that does. So it will select the contract address by default. It will ask me for the compiler type. I will select Solidity single file because I'm deploying a contract which is made up of a single file. The license is generally MIT, so I will just select that. And oh, my bad. Before that, I need to select the compiler version. So for that, I will go back to my IDE. As you can see, it is 0.8.7. So let's select that 0.8.7, and then we'll select the license type. As soon as I click on continue, it will now ask me for the Solidity contract code. Now the contract code is again available in our Remix ID. I'll just select all of it, copy it, paste it here, and it will ask me for some constructor arguments. Now this is again slightly nuanced, but generally it will be auto-filled. If it is not, you will have to generate it, but we will cover that in forward going sessions. So this is auto-filled. I'll just select I'm not a robot. I'll click on verify and publish, and I get the message successfully generated bytecode and ABI for contract. Now let's see what happens when I again go to this contracts transaction. So it says the contract address is 0400637, and now there's a green tick and the contract source code is available. So this also, facilitates other people being able to interact with my code. Now anybody can access my contract on Remix. They can go to robstonetherscan.io. If they have the address, they can view it and interact with my code contract directly. Now these functions are divided into read and write. They are not so in this Remix environment. So in Remix, but the functions are exactly same. So we have get options here, which gives me this. And similarly, we have get options here, which is giving me this answer. Rank be, Robston, rank be Goldie and localhost. It's also letting me select options. So if I pass it 0, I'll get the first option. If I pass it 1, I'll get the second option. If I select question, it will give me what is the best testnet. Similarly, I can call the write functions, but for that I will have to connect to Web3. Now again, since this is the this is a testnet, I cannot just depend on the JavaScript VM. I have to have the MetaMask extension or another popular wallet called Wallet Connect. I'll just go with MetaMask for now. Again, I'll select Bob admin and I'll connect. And now I should just be able to pass my votes. Okay, it says cannot read property of undefined because connect to Web3 did not go through, I think. Let's try to do that again. And there we go. It's connected this time. So now that I click on write, it will again open the pop-up. And as you can see, unlike the VM, I actually can see the gas fees that I have to pay to call this contract. So again, this is a good reminder that everything on Ethereum is paid and is completely, part of the decentralized finance ecosystem. So even if you want to call a function, which is just casting the vote, you will have to pay some gas fees. So once again, I click on confirm. And again, like the contract deployment transaction, this transaction is also going to take some time. Another interesting thing now that we are on the testnet is that when I read a contract, I don't have to pay any gas fees. So if I were to, again call this get options, it just returned me this string. If I were to call a specific option, it's calling the contract, returning me the value, but I'm not paying any gas fees. Why is that? Because I only have to pay gas fees when I'm changing the state of the Ethereum blockchain. When I call a write function, I'm changing the value of a variable there. So in write functions, when I'm casting a vote, I'm changing the value of a mapping that I have in the contract, which is changing the state of the entire blockchain. It is only for those functions, function calls, that I have to pay any gas fees. If it is for just reading the state, which you do through these read contract methods, you don't have to pay any gas fees. Let's go back to our transaction and see the status of that. Looks like it is still in a pending state. There are a couple of nifty things that you can do with MetaMask. So I'll go to my MetaMask extension. I can actually speed this transaction up by providing it to more gas fees. Now we are able to do this on the testnet because Ethereum here is completely free. But keep in mind that on the mainnet, if you get access to Ethereum, please don't do this unless it is absolutely required, because gas fees are very volatile on the mainnet, and you might end up paying a lot of gas fees without realizing what you're doing. So every time that you speed up, just make sure that you get the exact value, and you're only spending on what is meaningful. So I'll save it again, and let's just wait now for this transaction to go through. There we go. The transaction is successful, and I should be able to check that the casted votes for the 0th option. Okay, that is the vote count function. So if I pass 0 to it, I should get one vote count. So one person is voted for this contract. For the first option, if I were to select 1, I will get 0. So again, I was able to call the right function. Now the second time that I call right, this transaction should not be able to go through, because we had this require statement, if you can remember. Let's go back and look at the code. Now since I'm trying to cast it for the second time, I have already cast it, it should not go through. And MetaMask will actually give that information that this transaction is expected to fail. You can still click on I will try anyway and confirm the transaction, but it will fail, and which is why you will end up spending all these gas fees for nothing. This is a great facility provided by MetaMask, which is very helpful in situations when you're dealing with the mainnet, because here you can afford to spend these gas fees, but in on the mainnet you don't want to, and MetaMask will warn you when a transaction is actually likely to fail. So I'm just going to reject this transaction. I will come back to my contract code, and like I said, it is visible to everybody, and there we go. So we have basically learned how to deploy your contract to a testnet, and therefore by extension to the mainnet. This summarizes and finishes the first Solidity cohort that we have built, and thank you to everybody who was kind enough to join us on this journey. We look forward to creating more cohorts for you and seeing all of you there as well. Please let us know through comments, through our Discord channel, through our Twitter threads, or even through our website, what you thought about the course, what do you want us to build in the future for you, and if there are any improvements that you think we should be making to our content quality. Thank you everybody, and see you around.